So this video will be the third and final part of section 5.3, multiplying polynomials. This video will focus on the application problems that are typically associated with multiplying polynomials. So let's take a look at our first question. Our first example focuses on geometry, and it says that a closed rectangular box has sides of lengths n, n plus 2, and n plus 4. So here we have our box. One of the sides is n, one of the sides is n plus 2, and the final side is n plus 4. And the question says, write a polynomial function v of n that represents the volume of the box. So we need to remember that the volume of the box is going to be defined as the length times the width times the height. So here we're going to have n times n plus 2 times n plus 4. So I'm going to multiply the polynomials first. So I'm going to say that this equals n times, and I'm going to use FOIL, so I have n squared, outer times outer plus 4n, inner times inner plus 2n, and last times last, positive 4 times positive 2 is going to give me plus 8. Then I'm going to distribute the n, so I have n times n squared, that's going to give me n to the third. I'm going to combine like terms here, so I have 4n plus 2n, which is 6n. So when I multiply n times 6n, I'm going to get plus 6n squared. And n times positive 8 is going to give me plus 8 times n. So this is my polynomial function for the volume of the box. So part B says, what is the volume of the box if the length of the shortest side is 3 inches? So the shortest side is always going to be the side marked n. So if this one's 3, then we have 3 plus 2, which is going to give us 5, and 3 plus 4, which is going to give me 7. So I could figure this out by plugging in 3, 5, and 7 and just multiply 3 times 5 times 7 and get the answer. Or I could use the algebra and I could say, well, this is the volume of when n is 3. So I have 3 to the third power plus 6 times 3 squared plus 8 times 3. So 3 times 3 is 9, times 3 is 27. Plus we have 3 squared, which is 9, times 6, which is 54. Plus 8 times 3, which we know is 24. So I have 105 cubic units. Part C and D. Again, we have that same box, so I can redraw it on this screen. We have n plus 2, and n plus 4. It says write a polynomial function, a of n, that represents the area of the base of the box. So the base of the box here, the area function, is going to be defined as just n times n plus 2. So that's going to equal n squared plus 2 times n. This is a polynomial times a monomial multiplier. Our second part here, part D on this slide, asks us to write a polynomial function for the area of the base if the length and width increase by 5. And they want us to show that the polynomial function is really a of n plus 5. So here we have our box, and it's got n plus 2, and n plus 4. The area function that we just wrote, a of n, is n squared plus 2n. But they want us to consider a box where n plus 5 and n plus 2 plus 5. So this is n plus 5 times n plus 7, which is going to give me n squared plus 12n plus 35. And they want me to show that this is really the same thing as a of n plus 5. So remember what this means. This means everywhere we see n, we plug in n plus 5. So we have n plus 5 squared plus 2 times n plus 5. So n plus 5 squared, that's one of the special rules that we learned in the last video. So we have n squared plus 10n plus 25. So that takes care of this part. Plus, then we're going to distribute the 2 to the n. And plus 2 times 5, so plus 10. So we have n squared, that gets rid of this, plus 10n plus 2n gives me plus 12n. And plus 25 plus 10 gives me plus 35. So you can see these two really are the same thing. So we wrote a polynomial function for the area of the base if the length and width increase by 5. So this was that first part. Then it said show that the polynomial function is really a of n plus 5. And that's what we did right here. We showed that these two things are really the same. So our second example here is about revenue. It says that a shop owner has determined that the demand for his daily newspapers is given by the equation P equals 175 minus 0.02 times X, where P is the price of the newspaper in cents, and X is the number of papers sold. The total revenue, R, from selling X units of a product is given by the equation R equals X times P. And they want us to find the revenue equation for the shop owner's daily newspaper sales. So this is the first part. Find the revenue equation. So we know that R equals X times P, and we know that P equals 175 minus 0.02 times X. Those are the two things that we get from the question. So we have this, and we have this. So I'm going to take this value for P and I'm going to substitute it in right here. So this is going to equal X times 175 minus 0.02X. And so then by distribution I have 175X minus 0.02X squared. So this is our revenue function. And so that completes the first part. Then they ask us to find the revenue when 3,000 papers are sold. So remember, X is the number of newspapers sold, so what they're asking us to do is plug in 3,000 for X. So the revenue is going to equal 175 times 3,000 minus 0.02 times 3,000 squared. So we have 175 times 3,000. And check your calculator, but that should be 525,000 minus 0.02 times 3,000 squared. 3,000 times 3,000 should be 9 million. $9 million times 0.02. This should be 525,000 minus 2% of 9 million. That's going to be 180,000. So then 525 minus 180 is going to give us 345,000. And so we look back. One thing that's really important to notice here, we're talking in cents. So our revenue is going to be about $3,450. Or if you like, 345,000 cents. So now we've seen two real-life applications of when we could run into multiplying polynomials. Hopefully that makes it a little bit more clear why we need this information. And that concludes part 3 of section 5.3, multiplying polynomials.